For the use of actuators, we also provide an application case of using the STM32 microcontroller as the main controller. If you want to use the STM32 microcontroller to control our actuators, you can refer to this code. Before watching this video, please watch the Toddy-Bugger user guide page of the official document, which contains an introduction to each mode and almost all configurable parameters. The main.c file provides the simplest use case, including simple tests of current mode, profile speed mode, profile position mode, and MIT mode. We will introduce the most basic usage of actuators in conjunction with messages, which is also applicable to other control devices. When the actuator is powered on, it is still in the reset state, similar to the disabled state. To make the actuator rotate or output torque, the actuator needs to use this message to enter a certain operation mode first. The current mode is selected here. Before selecting a mode, we usually need to send a reset command to ensure that the actuator is currently in a reset state. For the functions of mode selection and reset, you can view the frequently asked questions from customers page of our official documentation. After entering the current mode, you can directly send this message to control the current size. Then comes the profile velocity mode. After entering the mode, you can use this message to control the velocity. In addition to the velocity value, this message also contains a current limit value to keep the current within the value range. This value does not distinguish between positive and negative. After entering the profile position mode, you can directly send a control message. The message contains not only the position value, but also the current limit value and velocity limit value. This mode is suitable for large angle control and cannot input position values at high frequency. The position mode is suitable for controlling small angle changes, and the position value can be input at a high frequency. This mode is often used for running tracks. For example, a sin-type position curve is defined here, and the position value is continuously sent at a frequency of 500 Hz. The actuator will rotate along this track. The usage of MIT mode is relatively flexible and diverse, which requires close coordination of the 5 parameters, including but not limited to the following usage methods. Please refer to the Using MIT mode page of the official documentation. First, control the current. Use this message to set Kp and Kd to 0. Then use this message to set the current value. The velocity and position values have no effect. Then control the velocity. You need to set Kd to a non-zero value, Kp to 0, and then send a control message. In addition to the speed value, the message also needs to include a current compensation value, which is usually the sum of the current required to offset the friction of the actuator and the current value calculated by the robot dynamics. Then, to control the position, you need to set Kd and Kp to non-zero, and set the velocity value to 0, and the message also needs to include the current compensation value. There is one thing we need to pay attention to here. When using this mode to control the position, it is easier to generate a large current, so we need to know the approximate range of the current value. For example, below, we limit the output current value to prevent the actuator from rotating at high speed. If you need to run a track, you should continuously send messages at a fixed frequency. The message should contain the current compensation value, the derivative of the position, and the position value. Here we take the sine curve as an example. In addition to the above messages, users may also use messages to modify PID and acceleration. For these, please refer to the Modify the PID parameter page in the official documentation. Finally, let's watch the actuator run.